So there we go. There's that information, and then I am out of your way. So take it away, Dr. Valdez-Jasso.
Hi, hello everyone. It's nice to see so many attendees. I guess it's almost quite the same ratio of professors for the class than attendees. If you don't mind, it'd be nice to see actual faces instead of blocks, if that's okay. If you're Zoom, don't be shy. Yay, thanks, Michael. Yeah, I guess Daniel, you're natural there. Uh, so I guess maybe I can just give you a really quick rundown into what the class I think is when we develop it, or we're planning some of the ideas. As you know, I have Ben Smarr here with our data in our data science field, bioengineering data science, and Joe Schoeneberg is in chemistry. It's chemistry, right, Joe?
It's pharmacology and chemistry.
Pharmacology. Okay.
It's mostly bioengineering anyway, so it's...
Oh, okay. I was gonna say I'm very chemistry oriented. Anyways, so yeah, so what we want to do is, of course, we deal with data, multiscale, and we want to make sure that we're giving you the right tools with machine learning to make sure you guys can be also staying on top of this field. And so the way we're going to do this, or we're planning on doing it, and hopefully successful, you guys are going to be our guinea pigs. We're going to split it in sort of like, I would say almost like two phases. The first phase is really going into like the foundation or the math a little bit behind a lot of these concepts. If you were to ask me, and I think several people in the field, you would probably say, this is like linear algebra, say a probability, just gone, out partying. And so I am going to be the one setting you guys up in terms of like the theoretical, the basis of it, trying to see how some very basic, nice fundamental concepts that hopefully you guys seen before in linear algebra are used to be built on. And so maybe a little bit more with me, you're probably going to be doing more on the homework on making sure that these concepts are more straight and how to build up on them. But then my colleagues here are going to really take it to the application side of things. And so they're really going to submerge you into their worlds. And so Joe is going to, and I'll let you talk more about it, but he's really going to be diving into the world of imaging, right? Processing data. Those files are humongous, and how to, well, I'll let him talk. And then Ben is going to then go into this whole idea of like, well, you're taking so much data, longitudinal data, and then the question again is, how do you process and use all that information to actually maybe inform or infer some physiological metrics from that. So I don't know if Joe and Ben want to chime in.
Sure. Yeah, so what we are doing in the lab is basically we have one of the 5 operational most advanced microscopes on the planet in the lab, and we produce 3 terabytes of data per hour. And we use advanced machine learning methods to basically segment and process these data sets. And so what I'm going to do in this class, or what I'm going to try to do, is we're going to take everybody from step 0, which is nobody has ever like even seen an image or what an actual image is about. And we're going to start with a Jupyter notebook, and basically we're gonna start from, okay, this is Python, this is a Jupyter notebook, and this is what an image looks like to a Python interface and to the computer. And then we're gonna basically go from that into like very, very basic image processing. Then we're gonna put the next layer of a little bit more advanced image processing, like how to segment images, how to track objects, that kind of stuff. And then in the next level, so we're gonna have basically 3 levels. The first level is to like never even seen an image in a computer before. The second level is the more advanced. Okay, now I can actually segment my images, I can track things in those images. And the last level is going to be, convolutional neural networks. If we have enough time, we're going to talk a little bit about autoencoders and more advanced image processing tools. So it's basically everything that you've heard recently about image recognition, all that stuff on the media, like the computer vision. I hope we're gonna end there basically. Like we're gonna stretch all the way from the basics all the way to you hopefully being able to train your own model in PyTorch. So that's the goal actually. So that's gonna be fun.
Super cool. So then riffing off of what are the basic stats, how does this work when you have image data? I'll be doing series data. So then we'll pivot for the last 3 weeks. A lot of the work that I do is in health algorithms, but fundamentally a lot of traditional machine learning fails in these spaces, not because the machine learning itself isn't very effective or useful architecture, but just because the feature engineering tends to get brushed aside. So much of finding the meaningful signal in a biological data set is knowing enough about the biology to contextualize when is this a meaningful aberration and when is this adding noise to my classifier, for example. This manifests in lots of ways, like biases in algorithms that work better on white men than anyone else, and that therefore have trouble being deployed in public health systems. Saying that something is invisible when in fact it's clear as day. It just requires the features be transformed very lightly. So we'll talk a little bit about biological rhythms. Why is biology more like signal generation than like static measurement? How does that change the assumptions about statistics that we've learned? You might think about in time series, you have a bunch of data, but they're not independent observations. They're tied to each other through time. So how do we deal with that? We'll be working in Jupyter Notebooks following up on Joe's work. So Joe's doing a solid for me and setting you guys up boot camp. We'll polish some of that stuff, but not make you do a hard pivot. Although I will say that signal processing in MATLAB is better. That'll be your problem.
Ooh.
And then this will give you the tools to figure out how to figure that out easily enough. And in fact, we'll probably show you an integrated notebook because one of the things Jupyter Notebooks can do is run lots of different programming languages. So yeah, hopefully should be fun, should be exploratory, should feel relevant by the end. If you didn't know any of these things, you'll have a whole heck of a lot of tools that are now very useful. Obviously in sort of 4 and 3 week segments, we won't turn you into craftsman masters, but fundamentally, I think you probably all know in this space, as long as you know enough to write the right Google search, you can find the code you need. So this will be getting you there.
Exactly.
So one thing that we had talked about in the past was hearing a little bit from you guys. What are you hoping to make sure we hit so that we can bake that in? Daniela, was there anything else as our ringleader? Was there anything else you wanted to say first?
No, not really. I mean, as I said, you guys are really going to be like the project data, playing with Jupyter Notebooks, and probably with me, you're kind of gonna be doing more, hand working paper then. If there is on the side note, I've been doing, so maybe just really quick mentioning that my background is in mathematics. So I am super excited. I'm going back to my roots. And then I'm debating quite if there's going to be a textbook. Those are changing all the time, but there is one that I'm really enjoying it, and that's currently linear algebra and learning from data. And it's really, really nice, like elaborating, building up into the right tools so that then you can go and play with all sorts of algorithms and understanding them and so forth. But other than that, really, it's questions you guys might have, or we're just having fun, right, guys?
So you guys, I tell this to all of my students. I will remind you all of us are professional air fillers. So we are perfectly good at filling up the great curriculum, filling up a 50-minute lecture or an 80-minute lecture. Because this course is new, our intention is to teach you things we think are interesting. I will simply remind you, we're not you. And so this is a great opportunity, as is early in the class, to say, hey, can we make sure to cover X, Y, and Z? And if you don't we won't have any insight that that's what you would have found more interesting, right? So definitely chew on it. You don't have to tell us right now, although it's fine to discuss, but certainly chew on it. Consider sending us a message before the quarter starts. If something's really important to you, we're probably pretty happy to fold it in.
I was kind of wondering, I don't have a strong background in mathematics or data science, so is there anything you would recommend reading or doing to prepare for the class?
I would say that I am not going to be expecting you to know or to be a master's on these. I would expect you to have familiarity in terms of having at least at some point taken linear algebra. I'd be happy to put material. We already have a Canvas, and we'll be happy to be putting text material for you if you want to start getting familiar with some of these ideas. I'm really not planning on spending much time on the operation of a lot of these things, more on the let's interpret and why is that we are obsessed with, eigenvalues, or why do we really need to know the singular values of a matrix, right? Why are those the fundamental questions in the field? So,
Will we have access to the Canvas now then, or at least before the start of the quarter?
I think so, because it's already published. I think it might require you being registered, but yeah.
Okay, I guess I'll take a look and email if I have more questions. Thank you very much.
Check it out. We can usually tell the support staff that run Canvas, hey, can you publish this early? They tend to be pretty accommodating. So I can't promise that, but if you can test us and tell us, hey, this is invisible, we can try to nudge.
Yeah. And then I think Joe wanted to say something.
Yeah, from my side, basically there's basically one link to a Python basics tutorial that I like to basically put out there. So so that you can refresh yourself a little bit, like what a variable looks like in Python, what a for loop looks like in Python, and you don't necessarily have to do this ahead of time, because basically in my lecture 1 bootcamp, we're basically gonna go through that, but we're probably gonna go through that a little bit faster because it's like a graduate level course. So if you basically want to refresh yourself, I'm gonna put that link on Canvas. And you can basically do this on your own time, ahead of time, and yeah, get a head start basically a little bit.
I just looked at my Canvas and I'm currently enrolled in the class, but I don't see the course in Canvas right now.
Okay,
something I need to do, or
I can look into it because I'm pretty sure I already published it. And so, but it might just be a matter of students officially can only start seeing information. Yeah, Joe.
And then I have another thing. So I typically like the courses that I teach to be as useful as possible to the students. So typically I have people to bring some of their own image data sets from their own work. And since you are graduate students, you probably have access to some kind of image data that you have collected at some point in your career. Maybe it's like the cell that you had on the microscope yesterday, but maybe it's like something else, like a Western blot that somebody else took a picture of with the camera, or an immunofluorescence or something. And so I would ask everybody to bring just one piece of image data set that we can work with in the class. So that would be great.
And I guess for my part, I'll say I'm not assuming that you'll have time series data from your experiments necessarily, although if you do, it's welcome. We will probably bring some data from PhysioNet, which is a resource we'll talk about. But if you have data you'd rather work on as yours, that's totally fine. The lectures will be more sort of framing the problems and discussing, and introducing you to techniques. And the homeworks will be practicals. And if they're done on data you care about, like, great, you're feeding 2 birds out of 1 handful of seed, as we might now say.
Marco, I have a question.
I was hoping to, while we were talking about things that we would like to be covered, mention something. So I've noticed with kind of a lot of these classes, the data science and other departments, that it'll usually be just a very clean, easy to use data set and like a Jupyter notebook or something. I was really hoping that we could do some of the like big data handling and address some things around that, like, yeah, like, and for IO and like how you kind of take these algorithms from a
Yeah.
small data set and use them on large data sets.
Yeah, no, absolutely. Not rocking the boat there.
In fact, we're gonna like
data management. How do you document all of these choices for reproducibility?
Yeah. Great, awesome.
In fact, you bringing all your own data sets is gonna be part of that. Basically, like, how do I get my own, like, because these, as you said, these curated Jupyter notebooks that work exactly on the data sets that we have prepared on Canvas, it's gonna be, you know, nice for the experience. But like later, when you're in your lab, you basically want to actually use this. So yes, so that's exactly for the purpose of you bringing your own data set, so that we can actually make it all work with your own data set. But I think what you addressed there, the kind of like, how do I scale this up to something bigger? That's a good point. I'm going to introduce that in the class. There's no real limit to how big the data sets can be that we generate. So
It's very cool.
Thanks.
How about you, Michael or Daniel?
Happy clams.
then you should bring some of your mito data,
So what?
mitochondria data. I know that that has some cool mitochondria.
Oh. Daniel, no, we cannot hear you.
Oh,
Not yet.
No. Yep.
There you go.
Okay, got it. I guess so structure-wise, you were saying that the course is going to be split up between the three of you, I guess like 4 or 3 weeks each. Is there a final, or do you have any ideas? No, just
No, the idea is going to be, again, this is a graduate level class. We're really doing this more like homework / project based. So for instance, for me, it's going to be homework just to get feedback, again, make sure everybody's moving along. So an instructor, that's very important for me. I think the men are probably going to be planning to do more like project. So actually working with data, can you process the data? Can you analyze data? But yeah, it's definitely hands-on, but there's no exams or finals.
okay. And this is more personal, but I have travel planned. Do you know if the course will be possible for remote or remote access? No. Okay.
No.
Okay.
So the students can contact you if and when they have questions before the course starts, I assume?
Yes, of course. Yes.
Cool.
Absolutely.
and I suspect that Canvas won't publish next quarter's classes while this quarter is still active, but we'll ask them and at least try to get that visible as soon as we're able to.
Would it be possible to have an email sent out with like some of those links if Canvas isn't able to be made accessible?
Yeah. As soon as it is, I can go ahead and send it.
That'd be great. Thank you so much. I really appreciate it.
Of course, yeah.
Yeah, and you had asked while we're on it, Caitlin, for the data science point of view, and I'm not anticipating, making this a hair-pulling algorithm design class experience. It's more, I assume this is your first time or many of your first times doing this kind of work. So it's more, what are the examples that help make clear why the principles matter or how you can translate them into your research. How do you look up and use different toolboxes? So, we'll have plenty of time to sort of tool on these things. I'll probably try to seduce my graduate students to come and help out giving technical support some of the time. So you should be well supported as far as that goes. The basic intro, making sure you can use Python in your environment makes a lot of sense, but I don't think you need to worry too much about advanced database structures or anything like that, prepping.
Okay, thank you.
Same goes for me, for my part. It should be fine. You're gonna be fine.
I mean, I think that at this point, and the kind of fact being a special topic class, it's more of I want to learn it and I want to figure it out how I can be applying this into my research. So how many students? I'm not sure.
I believe 18 signed up for today is what we were told, but we can't control, obviously, how many people in the end actually sign up. Something of that order, hopefully. Well,
cool. Well, thanks for having us. Thank you for your questions.
Looking forward to it.
Thanks so
Danielle, for
much.
organizing.
I'm sorry.
Yeah.
No, Kelly, thank you for helping and supporting and organizing.
No problem. Happy to help. And if anybody has any questions, of course, let me know if you want. And I'm happy to do anything I can to help. And I'm looking forward to the feedback from this course. I think it's going to be a lot of fun for a lot of folks, especially the 3 instructors. They've already been talking about it and being excited about it in their email exchanges. So that's been fun to see. So looking forward to hearing the students' feedback.
And we're volunteering this thing, so it's not like we were forced to do it. So I think you may get a different flavor in that regard.
Yeah,
Right.
I think it's going to work out great, and seeing what it contributes to the interfaces program is going to be fun as well. This has been something that's been in the works for a while. Dr. McCulloch's wanted it for a while, and so I know he's really glad that this is getting off the ground. So if I can do anything to help, let me know. And I'll send out an email that this video is available so other students can watch when they have time. 18 signed up for the open house today, but I think there's 44 seats for the course if I read the description correctly earlier today. So
yeah, I think that's the class capacity, but yeah.
And since this is the first time we're offering it, we don't really know how many we'll have sign up. I think we've already got a dozen enrolled. I'd have to double check with Vanessa. So very excited about it. So
Cool.
Okay.
okay.
Oh, you're on. Okay. Yeah.
Thank you.
Thanks,
Bye, everyone.
everybody.
Bye.
Bye-bye.